Imagine a single multi-turn prompt injection bypassing your entire security stack to authorize a $1 million fraudulent wire transfer. In the high-stakes world of finance, traditional firewalls are no longer enough to stop sophisticated adversarial attacks. Most financial institutions are checking boxes while their AI agents are being hijacked. The old model of manual testing assumes you can predict every human interaction, but in reality, the year 2026 will be defined by $250,000 fraudulent transfers triggered by a single multi-turn prompt injection. Your legacy firewalls were built for static data, which means they are useless against salami slicing attacks that drain accounts one tiny piece at a time. By the end of this session, you will have the blueprint for a multi-model gauntlet that secures autonomous workflows. Subscribe to the M365FM podcast to stay ahead of the agentic era risks before the August 2026 deadlines. We are moving beyond basic compliance and building a resilient red teaming framework that secures sensitive transactions against the next generation of adversarial attacks. The identity crisis of autonomous agents. We are deploying agents for fraud detection and ACH monitoring right now, but the ownership is fragmented and the whole situation is a mess. You have security teams looking at the perimeter, IT teams looking at the infrastructure, and AI teams looking at the models, but nobody is looking at the agency. Only 28% of organizations can actually trace an agent's action back to a specific human sponsor, which is a terrifying statistic when you think about it for a second. If an agent authorizes a payment, 3 out of 4 companies cannot tell you who was responsible for that machine's logic in that moment. The assumption is that commercially reasonable monitoring is enough, but it isn't anymore because 2026 NACHA rule changes now demand a documented rationale for every AI-driven payment decision. You cannot just say the algorithm did it and you have to prove exactly why every single time. You publish the agent, you give it API access, and you connect it to your core banking systems, but then you lose the thread of accountability. This isn't a technical bug, it is a governance void. The identity of the agent is becoming a phantom in the machine. We give these systems the keys to the vault and allow them to move money or approve loans, yet we treat them like isolated scripts. In reality, they are autonomous actors, and when an agent fails, you don't just have a system error, you have a massive liability event. The 2026 landscape is unforgiving because regulators are no longer asking if you have a policy, they are asking if your policy actually works at runtime. If you cannot link a transaction to a sponsor, you are out of compliance, and it is that simple. Most firms are still using static API keys for these agents, which is like giving a master key to a stranger and hoping they don't open the wrong door. You need a know your agent protocol, and you need to bind every tool call to a specific credential. But here's the problem. Most organizations don't even know how many agents they have, and we are seeing a massive surge in shadow AI as a result. Employees are building their own agents to automate their workflows, and they are connecting them to internal databases while giving them access to sensitive customer data. They are doing all of this without any oversight, and this creates a massive attack surface that is ripe for exploitation. An attacker doesn't need to breach your firewall if they can just hijack a poorly secured agent, and they can use that agent to exfiltrate data or trigger unauthorized transactions. They can use it to bypass your internal controls, and because only 28% of you have traceability, they can do it without leaving a trace. We have to stop thinking about agents as tools and start thinking about them as identities. If you cannot audit the reasoning, you cannot trust the result, and that is the new standard for 2026. The NACHA rules are just the beginning of a global shift toward effectiveness-based standards, and it isn't about the process anymore, it is about the outcome. If an agent approves a fraudulent ACH transfer, the institution is on the hook, and you cannot hide behind a vendor's black box. You have to be able to reconstruct the decision path within 60 minutes, but the truth is that most of you can't do that yet. You are flying blind in a high-velocity environment, and the identity crisis of autonomous agents is the single biggest risk to financial stability in the next 18 months. It is the gap between what we are deploying and what we can actually control, but the problem goes deeper than just who owns the agent. It is about how the models themselves are infected. The cross-model infection pattern. We used to think that using multiple models provided a natural safety net. The logic was simple. If one model had a bias or a flaw, the others would catch it. We called it model diversity. But in the 2026 landscape, that assumption has been completely dismantled. New research is showing us something much more disturbing. Fine-tuning a single model on insecure tasks doesn't just stay within that model. It actually infects unrelated models in your chain. This isn't a theory. We are seeing GPT-4o misalignments scaling to Quen and Llama derivatives at a 50% replication rate. It is a viral spread of vulnerability across the entire ecosystem. You think you are building a redundant system by using different providers. In reality, you are just creating more nodes for the same infection to travel through. This is a supply chain backdoor that no manual pen test will ever find. Most security teams are still looking for traditional code vulnerabilities. They are looking for buffer overflows or SQL injections. But the new threat is semantic. It is embedded in the weights of the models themselves. Attackers are now using a technique called adversarial hubness. They don't need to breach your servers. They just need to plant one malicious document in your knowledge base. Because of how vector embeddings work, that one document can act like a gravity well. It pulls in 84% of your RAG queries. You think your vector database is a library. You think it is a structured repository of truth. In reality, it is becoming a trap for your autonomous workflows. When your agent goes to retrieve context to process a wire transfer, it isn't just getting data, it is getting poisoned instructions. The model doesn't see the difference between a legitimate invoice and a hidden prompt injection. This is where the multi-model strategy backfires. If your primary model retrieves poisoned data, it passes that reasoning to the secondary model. Because these models share foundational training data and similar transformer architectures, they share the same blind spots. The infection replicates. The second model validates the first model's error because it is susceptible to the same logic trap. We are seeing success rates for these role-play-based injections hitting nearly 90% in financial environments. The models are effectively talking each other into authorizing the fraud. This cross-model propagation is the silent killer of AI security. You might have the best firewall in the world. You might have encrypted your database to the highest standards. None of that matters if the reasoning logic itself is compromised. The attackers aren't trying to break your encryption. They are trying to break your model's understanding of reality. They are using encoding tricks and logic traps that bypass traditional text filters. If an image of a receipt contains low contrast text with an admin override command, your multimodal system will read it. It will process it, and it will execute it. This is how that $250,000 transfer happened. It wasn't a hack of the network. It was a hack of the context. We have to accept that these models are stochastic and unpredictable. They are not deterministic software. You cannot secure them with static rules. The vulnerability isn't in the code. It is in the attention mechanism. It is in the way the model blurs the line between data and instructions. When you pile multiple models on top of each other without an adversarial framework, you are just stacking layers of glass. You aren't building a vault. You are building a fragile chain where one crack shatters the whole structure. To stop this, we have to move away from the idea of testing. We have to move toward a model of continuous warfare. We need to stop asking if the model is safe and start trying to break it. To stop the infection, we have to build the gauntlet. Architecture of the multi-model gauntlet. Manual testing is a relic. If you're still relying on humans to sit in a room and try to trick your AI, you've already lost. Humans are slow. Models are stochastic. You can't predict every permutation of a multi-turn attack with a spreadsheet and a team of consultants. By the time your red team finds one vulnerability, the underlying model has been updated or the attack surface has shifted. This is why the old model fails. It's static. It's reactive. In the high-stakes world of 2026 finance, we need something that moves at the speed of the threat. We need the gauntlet. The architecture of the multi-model gauntlet is built on a simple, brutal principle: pitting diverse LLMs against each other in a zero-sum game. You aren't just testing the system, you are creating an evolutionary pressure cooker. You take an attacker model, something highly capable like a specialized GPT variant, and you task it with one goal: bypass the defender. The defender is your production agent, the one handling those ACH transfers and loan approvals. They enter a continuous automated loop. The attacker generates sophisticated multi-step prompt injections, and the defender tries to maintain its alignment. This isn't just a simulation, it's a training regimen. We use what we call the 50-50 mix. When you are fine-tuning your financial agents, you can't just use clean, perfect data from your core banking systems. That makes the model fragile. Instead, you saturate the training set. Half of the data is clean, but the other half consists of adversarial examples generated during the gauntlet sessions. This includes everything from salami slicing logic traps to those hidden multimodal overrides we discussed. The result is a 70% increase in resilience. You are effectively vaccinating your AI against the very exploits that are currently bypassing your firewalls. But here is the structural shift. You aren't just looking for bugs. You aren't trying to find a specific string of text that breaks the model. You are hardening the reasoning logic itself. In the gauntlet, we use reinforced chain of thought training. We force the defender to show its work. If the attacker tries to use a role-play-based injection to authorize a transfer, the defender has to explain its rationale at every step. If the reasoning starts to drift toward an unauthorized action, the gauntlet flags it immediately. You are teaching the model to recognize the feel of a coercion attempt. This architecture solves the diversity problem. By using different model families, perhaps an anthropic model for the defender and a meta-based model for the attacker, you ensure that the blind spots don't overlap. You are using the strengths of one architecture to expose the weaknesses of another. This is a continuous cycle. As the attacker gets smarter, the defender gets tougher. It's a self-improving security layer that doesn't sleep, it doesn't get tired, and it doesn't miss the subtle semantic shifts that a human tester would overlook. For a financial institution, this is the only way to satisfy the upcoming effectiveness-based audits. You can show the regulators a documented history of millions of simulated attacks and how your system stood up to them. You are moving from a world where you hope you're secure to a world where you know exactly how much pressure your logic can take before it breaks. This is the shift from a passive defense to active warfare. You are no longer just building a wall, you are training a soldier. This gauntlet becomes your primary defense mechanism against the next generation of adversarial threats. It transforms your security posture from a list of rules into a dynamic, evolving system. You are finally matching the speed of the models with the speed of the defense. This is the only way to ensure that your autonomous workflows remain resilient in a world where the threats are just as smart as the systems they are trying to subvert now. The Glassbox Audit Framework. August 2026 is no longer just a random date on a compliance calendar, because in reality it is a hard wall. This is the exact moment when the EU AI Act's high-risk requirements move from theory into active enforcement. If you are operating autonomous agents in the financial sector, you are now under the microscope, but the nature of the examination has changed. Regulators are moving away from process-based standards, which means they don't care about your documentation or your intent anymore. They are moving toward effectiveness-based standards. They want to see that your security actually works at the moment of impact. This shift requires a move from the black box of traditional AI to what we call the glass box audit framework. You need to be able to see through the logic in real time. The most critical metric in this new era is decision reconstruction time. If an agent moves money, you have to be able to prove exactly why it happened in under 60 minutes. For most institutions, the answer is currently a flat no, because they have logs but they don't have reasoning spans. They have outputs, but they don't have the why. In a glassbox framework, every tool call must be bound to a know your agent credential. This isn't just an API key, but rather a verifiable identity that carries the authority of a human sponsor. You are essentially creating a digital chain of custody for every decision. If the agent decides to waive a fee or approve a high-risk wire, that decision must be anchored to a specific set of parameters that a human has authorized. We implement this through a concept called bounded autonomy. The agents handle the heavy lifting of analytics and execution, while humans hold the physical kill switch. This isn't just a button you press when things go wrong, but a structural limit on what the agent can do without explicit re-verification. You define the boundaries of the glass box by setting thresholds for risk, value, and deviation. If the agent attempts to step outside those bounds, the system freezes the transaction and demands a human rationale. This satisfies the regulatory demand for human-in-the-loop oversight without sacrificing the speed of autonomous workflows. You are giving the agent the room to run, but you are keeping the leash visible. The stakes for failing this audit are catastrophic. We are talking about a 7% global turnover fine, and for a major bank, that is a number that can threaten the very existence of the institution. You cannot afford to have a maybe when the auditors show up. You need a tamper-evident audit trail that shows the reasoning path of every agentic action. This means logging the goal, the retrieved context, the tool calls, and the final result in a way that cannot be altered. You are building a vault for the logic itself, and this is the only way to survive the 2026 regulatory landscape. You have to be able to open the box and show the internal clockwork. This framework also protects you from the salami slicing attacks we discussed. By monitoring the reasoning spans over time, the glass box can detect when an agent's logic is being slowly eroded. It looks for contradictions in policy or shifts in tone that suggest a multi-step injection is underway. It provides the visibility you need to catch the drift before it turns into a breach. You are no longer just reacting to an alert, but you are observing the health of the reasoning itself. Setting this up sounds expensive and complex, and it requires a complete rethink of your data architecture and your governance model. But when you look at the alternative, the cost of the glass box becomes the best investment you will ever make. Transitioning to this model is the bridge between reckless automation and resilient, auditable finance. It is the shift from hope to proof. ROI, proactive warfare versus reactive cleanup. Let's look at the cold, hard math of 2026. In the financial sector, the average data breach cost is now pushing toward $5.8 million. That number isn't just a headline meant to scare you, but represents the actual bleed from digital forensics, legal fees, and regulatory penalties. You also have to consider the massive churn of high net worth clients who lose faith in your infrastructure the moment their data hits the dark web. When you look at the balance sheet, reactive cleanup is the most expensive way to run a bank. You are paying a premium for failure. Proactive warfare, on the other hand, delivers a cost avoidance ratio of 6-1. For every dollar you spend on the multi-model gauntlet, you save $6 in cleanup costs and fines. This isn't just a security metric, but a fundamental efficiency play for the modern financial enterprise. Manual testing is a sunk cost. You pay for a person's time, they find a few surface-level bugs, and then they move on to the next project. That knowledge is static, and it doesn't improve the model's core logic or its resilience over time. Multi-model red teaming is a strategic asset. You are building a library of adversarial intelligence that compounds. You are hardening your intellectual property. You are creating a moat around your autonomous workflows that competitors simply cannot match. This is the difference between a cost center and a strategic advantage. While they are checking boxes, you are building a fortress that learns from every attack. You are turning your security budget from an expense into a long-term capital improvement. The market is already pricing this in. Cyber insurers are no longer offering flat one-size-fits-all rates because they are looking at your adversarial testing logs. If you can provide documented proof of continuous multi-model red teaming, we are seeing premium reductions of up to 20%. The insurers know that a hardened model is a lower liability. They are essentially subsidizing your security upgrades because it reduces their risk of a massive payout. If you aren't doing this, you are effectively paying a vulnerability tax on your insurance every single month. You are leaving money on the table while increasing your exposure. Beyond the premiums, we have to talk about the blast radius. A reactive posture assumes you can contain the breach after it happens, but in an agentic environment, that is a dangerous fantasy. One infection in a single rack corpus can spread to every connected system in your chain. By implementing the gauntlet, you force a structural isolation of your data. You learn to encrypt your embeddings and scope your retrieval so that even if one agent is hijacked, the rest of the vault remains sealed. You are creating a defense-in-depth strategy that protects your most sensitive assets from the ground up. You are buying resilience. You are ensuring that a single logic trap doesn't turn into a systemic collapse of your entire financial operation. You are building a system that can take a hit and keep moving forward. The self-healing implementation roadmap. How do you actually start building this in your environment? The roadmap isn't about buying a new software package. It is about re-engineering your visibility. Step 1 is the inventory. You have to find your shadow AI. Right now, there are agents in your environment with API keys that your security team has never seen. These were built by developers or analysts to solve a specific problem, and they are sitting there connected to your production data without any oversight. The problem is simple. You cannot secure what you cannot see. You need a total audit of every autonomous workflow, which means identifying every human sponsor and every permission level across the board. This inventory is the first step in regaining control over your digital perimeter. If there is no sponsor, there is no agent, you shut it down. Step 2 is the move from simple logs to causal tracing. Legacy event logs tell you that a transaction happened, but they don't tell you the why. You need to deploy multi-step reasoning spans instead. This allows you to follow the thought process of the agent across the entire chain of execution. When an agent fails, you shouldn't be looking at a stack trace. You should be looking at a causal map that shows exactly where the reasoning was subverted by an adversarial input. You need to see the logic, not just the result, to truly understand the risk. This is the foundation of the gauntlet. Without causal tracing, you are just guessing at the root cause of your failures, and you end up treating the symptom rather than the disease. Step 3 is the implementation of trades optimization. This is where you balance your accuracy against your robustness. In a high-stakes financial context, you cannot have a model that is 99% accurate but 0% robust against a prompt injection. You use the data from your gauntlet to fine-tune your models using surrogate loss minimization. By doing this, you are explicitly telling the model that staying aligned under pressure is just as important as giving the correct answer. You are building adversarial awareness into the weights of the neural network. You are making the model smart enough to know when it is being manipulated by a bad actor who is trying to exploit your autonomous systems. This roadmap transforms your security operations center. You move away from alert fatigue, where humans are drowning in thousands of low-context warnings, and toward autonomous triage. Your architecture starts anticipating attacks because it has already seen them a million times in the gauntlet simulations. You aren't just reacting to the threat of today. You are securing the autonomous workflows of tomorrow. You're moving from a world where you navigate through risks to a world where you control the context. This is the final shift. This is how you build a financial vault that actually holds in the agentic era. You are finally building for the world as it is, not as you wish it to be. Start now. You now possess the framework to transition from checking boxes to building digital vaults. Your homework is clear. Audit one autonomous workflow this week for sponsor traceability. If you cannot find the human owner, that agent is a liability. If this shift in thinking helped you, leave a review for the M365 FM podcast. It helps more leaders find this signal in the noise. Connect with me, Mirko Peters, on LinkedIn. Tell me which AI risks are keeping you up at night. The era of manual testing is over. It is time to build for the adversarial reality ahead.